Okay, thank you for the permission. All right, let's begin. So Manish has not come. He might join us in a little while. Let us bow our heads for prayer. Our Father in heaven, we praise your name this morning. Thank you for your goodness, your faithfulness, and your love. Thank you that once again we have this wonderful opportunity to meet together as a class, realizing that you're the source of wisdom and understanding. We commit all our class activities to you today. We pray for your guidance. Bless us in our discussion. Help us that things will be made clear, especially to my students. And I pray that you'll please help me to be able to do my best to make things easier for them to understand. And it is only through you and in you that these things will be accomplished. Guide us throughout this day, we pray in Jesus' name. Amen.
Amen.
Amen. Okay, now I have seen, just now, two of you submitted your homework. Of course, Rachel also did hers, but yeah, I will just, whatever you have done, I will just write the solutions but you have the answers as already we, I chose the ones with answers in the appendix. And so I hope that you tried your very best to get the answer, of course, making sure that the processes would be done correctly. So we'll continue solving the real world problems and then move on to maybe higher order equations because we are just more into linear equations. Okay, so we'll talk about the exercises or so after I have given you my feedback on what you have done so far. So let me just share my screen. Okay. So anyways, February 13, just advance happy Valentine's Day to all of you. Okay. All right, so we'll continue with solving real world applications using a formula. Okay. So we'll talk of I hope you remember formula for perimeter, formula for area, formula for volume, and many other things on formulas in geometry. So when we talk of perimeter, what is a perimeter?
It's the outside of a rectangle or square.
All right. In other words, that is the we call it the distance around a certain geometric figure. And this one is a perimeter of a rectangle. So how do you find the formula? How do you find the perimeter of a rectangle?
You add the sides.
Add the length of the side.
Yeah.
Okay, so a rectangle, of course, has four sides. The width with equal lengths and the the length as well as the width. And because this width would be the same and the two lengths are also the same, therefore we just have that formula 2L plus 2W, where your L is the length and the width. So that's the same as L plus width plus width. Okay? So that's 2L plus 2W. So it says the perimeter of a rectangular out patio is 54 feet. And the length is 3 feet greater than the width. What are the dimensions of the patio? So what will be, we will say let me write pen. So what will be your X? Okay, it says the length is 6 inches more than the width. So we'll have now let X be what? The width or the length?
This is a different one.
Yeah.
This is
So from this statement. The length is 6 inches more than the width. So what will be our x so that the other one will be represented by x also? So if the length is 6 inches more than the width, what will be your x? Is that the width or the length? Reading that statement.
The first one?
Yeah, the length. Okay, because it's from there that we'll have to make representation of the unknown. What we're looking for is for us to be able to find the area of. Sorry, what happened? The length. I think I moved. Sorry, yours. That's what you're saying. That one is already different. The perimeter of rectangle outdoor patio is 54 feet. The length is 3 feet. Sorry, it's 3 feet greater than the width. So what will be our x? The length is 3 feet greater than the width.
Okay.
So we need to represent the length as well as the width. So how do we represent the width?
X.
X, all right. So it's the width there because it says the length is 3 feet greater than the width. So that this is our width, all right. And how do we represent the length?
X plus 3.
Yes, okay, that's it. So let x be equal to the width, x plus 3 is the length. And so putting in the width and length in the formula, and it says the perimeter is 54 feet. So from the formula P is equal to 2L plus 2W, your perimeter is 54, right? Is equal to 2, your L is x plus 3 plus 2, and your width is represented as x. So that is now our equation. And once the equation is done, then you can easily solve for the value of x. And as soon as you are able to get the value of x, which is your width, then you will be able to identify the length. Right. So what's the answer?
2x plus 2x for x. 54 minutes minus 3.
48. 12. X equals 12.
All right. Okay. So we now have 54 is equal to 2x plus 6 plus 2x. So I just put, it's always good to put the x's at the other side. So 4x is equal to 54 minus 6, which is 48. So x is equal to 12. And there, this is now our width. And what will be our length? It will now be x plus 3, all right? Which is 15. So it's good to check. Many times it's always good to check. So you now say 2L, so that's 2 times 15 plus 2 times 12 is 30 plus 24 is equal to 54. So therefore, we now say that the dimensions of the patio would be width is 12 and the length is 15. Yeah. So that's kind of, yeah, just knowing how to represent, and as soon as you know the formula, then it's a matter of substituting to your formula. This is okay?
Yeah. Yes.
Yeah, all right. So let's now proceed. Sorry for putting, okay, solve this problem. You are given the perimeter and you are looking for the area. We call this as two-step problem because it's from the formula for the perimeter. All right. So these are the formulas I just would want to show. So we have the perimeter and the area.
Is 48.
The length is 6 inches more than the width.
Yeah, and it's also good in the final answer, we put the unit of measure. So actually the previous problems, we should have 12 feet and 15 feet. And in the formula for area, length times width, just the same. Your L is the length and your W is the width. Yeah. So from the perimeter formula, you will be looking for the length in the width and then use the area formula in order to find the final answer of the area of the graph paper.
The width is
Width is?
9 inches
Yes.
and the length is 15.
All right. So knowing now the width as 9 inches and the length as 15 inches, then what will be the area? And so you now use that second formula for the area, which is length times width. Okay? Final answer?
135
All right. And you put that, what will be the unit of measure for area?
Inches squared.
square.
All right, we call it square inches. All right. So you just, okay, so you say your X is your width, your X plus 6 is your length. And so you now have 48 is equal to 2 times X plus 6 plus 2W. And from there, of course, anyway, 48 is equal to 2X plus 12 plus 2W. 2, why did I put 2W? 2X. Okay, sometimes it should be X. Oh, yeah, so 2X, 2X. And from there, you already got your X is equal to 9, which is the width. Your X plus 6 is equal to 15, which is your length. Your area is equal to 9 length times width. 15 is just the same. 15 times 9 is 135 cube square inches. So 135 square inches. Oh, so I think those are easy problems that we are able to do. Okay, now this time we talk of volume. Yeah, that's a formula for the volume of a box. It's just length times width times height, where L is length, W is width, and H is height. Okay, solve the problem. Okay, this must have there, comma. Find the dimensions of a shipping box given that the length is twice the width, the height is 8 inches, and the volume is 1,600 cubic inches. So the height is already given. You just have to look for the dimension of the length and the width, given that the volume is 1,600 cubic inches. So the process remains the same. We're just using different formula.
Eight inches. The length is 12, the width
So you already know the height to be 8 inches.
and the dimension.
And you know the volume. These are the given facts, 1,600. So you're looking for the length as well as the width. So you represented your width as x, right? And your L is?
2x.
Okay. Twice the width, which is 2x. So we just substitute. You know the volume. You know your L to be 2x. So we just make use of our some properties of radicals there. Answer?
Uh, 10, x is 10.
Okay. The width is 10. So your
So-
length is
20.
20, and your height, of course, is already 8. That is given. Okay, yeah. So your volume is 1,600 is equal to your length is 2x, your width is x, and your height is 8. Okay. So you now have 1,600 is equal to 16x squared divided by 16. X squared is equal to 100. So x is equal to 10, which is your width. 2x is 20, which is your height. So now your final answers would be, this one is of course inches. This one will also be 10 inches and 20 inches. Okay. So that's just using some formulas. So we now have 10 times 20 times 8 gives you 1,600 cubic inches. Let's proceed. Another one, okay. Where here it's immediately the area of the rectangle. It's given to be 91 square inches. The length is 6 inches more than its width. We want to find the dimensions of the rectangle. That's another. So you know the formula to find the area, which is length times width. Okay. All right. So just for, this one is, because I want this as my introduction to our next way of looking for solutions of some equations. So we'll always have let x be equal to the width, and yeah, it just so happened that we always have that. Of course, you now have x plus 6 is equal to your length, and the area is 91, of course, square inches. All right, so if the formula for area is length times W, then we now have 91 is equal to x plus 6 times x. So you now have 91 is equal to x squared plus 6x. So we are now into quadratic. In other words, it's not anymore a linear equation. It is a quadratic equation. So that's the next thing we would want to learn, how to solve quadratic equations. So before we solve 91 is equal to x squared plus 6x, let us consider a definition of quadratic equation. And so the quadratic equation is actually a second degree polynomial because your highest degree of that you have right there is 2, okay? So you now have ax squared. So the highest degree, of course, this one is the leading term. This one, the degree is 2. Where your A, B, and C, of course, are real numbers, and that A should not be equal to 0, because if that is 0, then you will have, it will boil down to a linear equation. So your A must be not 0. And so for us to be able to solve the quadratic equation, we will use what we call the zero product property. And that means that if we are able to change the ax squared plus bx plus c into factors, it says that if these two factors would be equal to 0, then the first factor, which is your a, will also be equal to 0, and the other factor, b, will also be equal to 0. And so this only tells us that we'll have to solve quadratic equations by different methods. And one very basic method is we call factoring. Okay, so we will be again going back to factoring. All right, so let's go back to our problem. And I think we ended saying that this is the same as 91 is equal to x plus 6 times x, which will give you x squared plus 6x is equal to 91. But we'll have to change this to a quadratic equation by equating it to 0, and which means that we'll have to add or subtract 91 both sides. So you'll have now x squared plus 6x minus 91 is equal to 0. And so we will do factoring, right? So what are the factors of negative 91 such that one is, when we subtract, the result is 6. Okay, so 91. What are the factors of 91? $91 can be divided by what?
13. Negative 13 plus 7.
All right. So you're saying 91 can be, two factors of 91 would be 13 and 7. All right, because that one is actually 13 times 7. But we want positive x, positive 6, I should say. So it should be 13 and negative 7, because 13 minus 7 is 6. Okay, so this will now become x plus 13 x minus 7 is equal to 0. Yes, because 13x minus 7x is 6x. And according to the zero property, we can equate x plus 13 is equal to 0. X minus 7 is equal to 0. So there will be two factors, of course, and there will be two values of x. And in this situation, from here, you now know that x is equal to negative 13. And here, you'll have x is equal to 7. But because this one is a real world problem, you're looking for the dimension. Which solution will you choose?
7.
All right. It's impossible to have a negative 13 there, okay? So therefore, our x is equal to 7, which is now our width. All right, but just the same anyway, if the width is x plus 6. So that's it. That is now x is equal to 7, and therefore x plus 7 is equal to 13, which is our length. And so we now talk of inches. We'll now talk of this as inches. So the dimensions of the rectangle would be 7 inches as your width and 13 inches as your length. Okay, so that's the first process of solving quadratic equations, and that is by factoring. So that's why I was telling, we were saying that whatever we have discussed in our algebra essentials would really be used in subsequent discussions. All right, so let's just practice solving quadratic equations by remembering how to do factoring. So we'll begin with factoring. Of course, there are other ways of solving quadratic equations, but the basic is what we call factoring. So I'll proceed. Okay. So to solve a quadratic equation, just to remind us of the steps, what we need to do is make sure that we get the equation into the standard form. So if your constant is at the right side, make sure that you equate that to 0. All right, I'm sorry. And then, so that's in that problem of x squared minus 4x minus 21 is equal to 0. That is already of the standard form of your quadratic equation. And then we just factor the quadratic expression. What are the factors of what would be the factors of x squared minus 4x minus 21?
7 and 3.
All right, so you now have x and x. One is 7, the other is 3. But which one will be minus, which one will be plus?
-7 and +3.
All right, so minus 7 plus 3. Minus 7x plus 3x is minus x. So you now have x minus 7 is equal to 0. X plus 3 is equal to 0. Therefore, x is equal to 7. And x is equal to -3. So this one is not real world. So you will have two solutions. Okay. And I think we now can do the substitution. 7 squared is 49 minus 21 is oh yeah. Yeah. So you know say 49 minus 28 minus 21 is equal to 0, right? It's 28 plus 21 is -49 plus 49 is equal to 0. If we substitute -3, that will be +9 minus 12, that will be plus minus 21, that's also equal to 0. So we call this actually the roots of your quadratic equation. It's a root when we substitute and it will be equal to 0. So that's the steps. So just for practice, okay, let's do the next one. All right, okay. 4x squared plus 15x is equal to -9. It's now making it a little bit bigger, okay? So this problem, it is not in standard form. So you will have to transform it to its standard form. So you know with 4x squared plus 15x plus 9 is equal to 0. All right, factor. Factor 4x squared plus 15x plus 9 is equal to 0. You can do your factoring by grouping, if you still remember that, right? Or you can just do it directly if you wish to. So if it's easier for you to do factoring by grouping because it's more systematic, then it's better to do that.
Yeah, I got it.
Yes?
Mm.
Factors?
X is negative 3/4.
Okay, so it's negative 3 and
3/4
negative 3/4. Okay.
and minus 3. That's the other X.
Mm-hmm. All right, so if you did factoring by grouping, or maybe because it looks like you got, it's either x plus 3, 4x plus 3, right? Those are your factors. So you actually, one way of doing it, one thing is because if you don't do factoring by grouping, you do trial and error, because 4 has either a 4 and a 1 or a 2 and a 2. So you can actually do that if you just decide, oh, it's 4 and a 1. So you now have 1 and 4, and then 3, 9 would be either 9 or 1 and 1 or 3 and 3. And then just put it in the proper position. Yeah. Otherwise, you would say 4 times 9 is 36. And the sum of, we now have 36, that is 12 and a 3, and 12 plus 3 is 15. So then you can do grouping and you get the same answer, x plus 3 times 4x plus 3. And so, of course, you now have x plus 3 is equal to 0. 4x plus 3 is equal to 0. So x is equal to negative 3. X is equal to negative 3/4. All right. Is that fine? Okay, these other ones. 9x squared. Yes, question?
No, I mean, if you do, because I did 9 as it is, and I separated the 4x squared, 2x, 2x. Because it does
All right,
give
and then what did you get?
1/2. X is 1/2.
All right, so what were the factors you got when you separated by 2x, 2x? Did you get 15x at the middle?
Yes.
All right, so what was your factors?
Oh, no, it's
All
wrong.
right, yeah. So the middle term will not be 15x.
I wrote the equation wrong. I put minus.
Oh,
Oh, okay. You put a minus. Yes. Yeah, because we have to transfer the -9 to the other side, and therefore that will now be a +9. So if it were a -9, you'll correct there. All right. Yeah, if it's a -9. All right. That number 3. You try to analyze number 3 and see how it can be factored more easily. Many times when we see that the first term is a perfect square and the second term is also, the last term is also a perfect square, then you would have some suspicion, okay? Hint that, oh, this might be a perfect square trinomial. But it just so happened that in number 2, you know, twice the product of 2x and 3x will not be 15x. So that is not a perfect square trinomial. So for number 3, 9x squared is a perfect square. 4 is a perfect square. The square root of 9 is 3. The square root of 4 is 2. So 2 times 3 is 6. And you find 12 at the middle, which is twice the product of the first and the last. The square root of the first and the last. So number 3 seems to be a perfect square trinomial. So you always do that analysis so that you don't, you know, because once you know that it's a perfect square trinomial, it is really easy to do the factoring. Okay, so let me just erase all the inks. So what are the factors of number 3?
I'm getting fraction.
Does everyone agree that number 3 is a perfect square trinomial?
Yeah. I
Mhm.
think so.
If it is so, therefore, immediately you know how to factor. You know, say get the square root of the first, get the square root of the second, follow the sign of the middle term.
Did factor.
And they are just the same, so you just have to have, in this situation, you will only have one answer, okay? So you now have 3x minus 2 is equal to 0, 3x is equal to 2, x is equal to 2/3. Yes. So for a perfect square trinomial, you will only have one answer. It's just
9 is perfect square.
2/3.
Mhm.
Yeah, which is that? When you multiply x squared, it's 4/9. So that will be 4 minus 12. That will be 8 plus 4 is equal to 0.
How did you
All
do
right.
it? I got that when I separated 3x minus 2, 3x minus 2.
I just did grouping.
Yeah, x minus 2. For x equals to minus 3.
No,
that's
it's-
3. Yeah, I did like this also. I
So
got
what did you
fraction.
get? Yeah, the answer is 2, I think. So fraction.
I got a fraction number 2/3.
Yeah.
Mhm.
Yeah, x
Yes.
is 2/3. Yes.
There are fractions in math.
Is Rachel there? I am not seeing.
Yes, is, oh, you are here.
Huh?
Oh,
Okay. I want to make sure that I see your face every time we meet.
How
silent
did you
watcher.
get minus 3? Because x should be
All right. So
3.
is that okay? Your x is 2/3.
It's 4x equals minus 3.
Mhm.
Write this separate.
Okay, number 4. Answer.
Oh,
Mm.
We
Oh,
call this
that's a,
difference of,
it's a perfect something.
Square.
it's not really, okay, it's a difference of 2 squares, but not perfect yet. There's a difference, okay? Okay, x squared minus 9. So what are the factors of x squared minus 9?
Plus
3x
3x minus 3.
All right, x plus 3, x minus 3 is equal to 0. So x plus 3 equals to 0. X minus 3 equals to 0. So x is minus 3 and x is equal to 3.
Yes.
Yes? All right. So there will be 2 factors there because minus 3 times minus 3 is 9. 3 times 3 is equal to 9. Oh. So looks like that
Cool.
one is an easy thing to do, right?
Okay.
Yes, no problem. Quadratic equation. Now,
I know.
let's have a polynomial. of higher degree. Okay, but just the same, we will make use of factoring. So most of the time, whenever I have a polynomial of higher degree, you would be suspecting that perhaps in that equation, we can factor the greatest common factor, which is a monomial, before factoring whatever other factor would be. So we now have minus 3x cubed minus 5x squared minus 2x is equal to 0. From this minus 3x cubed minus 5x squared minus 2x, is there anything common?
X.
Oh, yeah.
Right. So it is always good that your the leading one would be, when after factoring, would be a positive. So I would rather have my common as minus x, okay? So that the one inside will have a positive sign. So what remains there will be 3x squared minus 5x minus 2 is equal to 0.
Should it not be plus?
It's
Actually,
plus.
sorry. Thank you. Okay, we are all awake. Okay. 3x squared plus 5x plus 2. So it's just easy for me. I'll just put a bar, a line, a vertical line. Okay, good. Okay, so now we have 3x squared plus 5x plus 2. We can now just factor. So it's still factoring. So what are the factors of 3x squared? That one is easy. Just put here 3x and x.
And X plus
And
2.
then decide where you, because the factors of 3 would be 3 and 1. And then you have a 2. There are only two factors, 2 and 1. So just decide where to put the 2 and put the 1. So what will I, and both of them are plus, so it will now be plus. What will I put here? 1
It's
or
a
2?
plus 2.
3x plus 2 or 3x plus 1?
3x plus 2.
All right. And this is the 1 because 3x times plus 2x is equal to 5x. All right. That's great. So equating 0, immediately give the answer. What's the first? There will be 3 answers. Okay? The first
Is it
answer is x is equal to 0, right? The other answer from 3x plus 2 will be equal to?
And negative 2/3.
All right. And the other answer will be x from x plus 1 will be x is equal to negative 1. So from that equation, we now have
Negative
x
2/3.
equal to 0, x is equal to negative 2/3, and x is equal to negative 1. Yeah. Okay, so just a little practice. It's just the same. Sometimes I would have maybe not. Yeah, I'm giving easy ones where your common factor is not. You don't have to think of what's what are the factors of 11 and 10, because I just have x cubed plus 11 x squared plus 10 x is equal to 0. So we're solving some simple problems. So, okay, do that, and then we will proceed to another way of solving quadratic equations.
x equals to 0, x equals to minus 10, x equals to minus 1.
Okay, yeah. So x is equal to 0 is equal to minus 10. X is equal to minus 1. Good. All right, no problem. That one is another, just an easy. Okay, so let's proceed. We will now talk of square root property, which is actually very much whenever you now have a perfect, difference of two squares, all right? For the difference of two squares, but the square root property will be more general when we have just a square and then a constant, all right? So you know how to solve x squared minus, x squared minus 9 or x squared minus 16 because you can factor. But when your the constant is not a perfect square, then we better hold on to what we call the square root property. So the square root property is with the x squared term isolated, where your x squared minus 8 is equal to 0, you isolate your x squared and have a constant at the other side. Then it says if x squared is equal to k, then x is just getting the plus or minus of the square root of your constant. Reason is we're saying that if you have an x squared minus 9, then x squared is equal to 9, then x can be a plus 3, it can also be a minus 3. So this is one simple, a property that can easily solve a quadratic equation with an x squared and a constant. All right, which is minus definitely because we cannot have an x squared equal to a negative number because the square is always positive. So with x squared minus 8 is equal to 0, so according to the square root property, just isolate your x squared and that is equal to 8, right? So that your x will now be extract the root of x squared, that is x, but of course, you now say the square root of 8 plus or minus. But then we can simplify. How do we simplify square root of 8?
4 times 2.
Okay, so again, we are remembering what we have discussed previously. And therefore, it's plus or minus 2, the square root. So that's our square root property. That's another simple kind of solving. All right, okay, let me erase all and let us try some other things. Okay. So I have 4x squared, x squared plus 1 equals 7. So we isolate the x squared term and then do some simplification before moving on to using the square root property.
X equals to plus or minus 2. X equals to plus or minus 2.
Okay. Okay. Does everyone agree? So take note, that's 4x squared plus 1 equals 7. Oh, how about Bethany, what's your answer?
Then it would be 2x.
X is equal to plus or minus 6 over 4, the square root of 6 over 4.
But then you will have to, the 4 can be taken out, all right?
Yeah.
Square root of 4. Yes.
Oh, it's
So
6.
you actually have 4x squared is equal to 6. Because 7 minus 1 is 6. So your x squared is equal to 6 over 4. But I think it's easier to you know 6 over 4 has a common of 6 and 2. 2 can divide 6. 4 can divide 6. You can immediately do that division, okay? So 6
Mhm.
fourths is the same as 3 halves, right?
Uh,
6 over 4 is the same as 3 over 2. Okay. So now, using the square root property, x will now be equal to plus or minus the square root of 3 over 2.
So what is squared here under the radical?
X.
Ah?
Is the entire fraction under the radical?
Yes, that time is in the entire radical. Now, we learned that's supposed to be but as of the moment, I would have that as the square root of 3 over 2, or otherwise, the more simple one, okay? So like Bethany is saying, from there, you say x is equal to plus or minus the square root of 6 over 4. But the
Yeah.
square root of 4 is 2. So you now have x plus or minus 1/2, right? I'll get the square root of 4 to be 2 times the square root of 6. Or you now can just have plus or minus the square root of 6 over 2. Which
Well-
can be, from here, the square root of 3 over 2, all right, the whole fact, everything, over the square root of 2. You remember that we say we do not want the square root in the denominator. So this will be the same as the square root of 6 or over 2.
6 over
Same
2.
thing.
Yes, that's what I'm saying. So if you do this, you still need to rationalize the denominator. But if you
Yeah.
go directly here, where you get the without doing this, so there are different ways of doing so. Without doing the changing it into the lowest terms, okay? Then you now can get the square root of 6 all over 2. So any of this, of course, there's an extra step for this one because you need to rationalize the denominator. Yes. So whatever you do, as long as you're following the process, then you'll arrive at the same answer. So your final answer supposed to be here will be x should be equal to plus or minus the square root of 6 all over 2. Okay. Lastly, for this one is just easy one. So I will not give so much. I just give you more exercises. Okay, so 3 times x minus 4 squared is equal to 15. Solve. Answer? Final answer. Oh, Manish, do you have an answer?
No.
Why? Okay. So what first did you do? What would be the first step?
I'm confused with the brackets, how to
All
subtract.
right. Anyway, okay. Can we not make this simpler by dividing both sides by 3?
That never occurred. Yes.
All right. Because
Mhm.
you need to isolate the one with a square. It's not necessarily x squared, but it is anything with a square. So you isolate that. So dividing this by 3, you now have x minus 4 squared is equal to 5. And then this extract the square root of both sides. What's the square root of x minus 4 squared?
Wait.
When we extract the root, we just divide the exponent by 2, right? So if I extract the root of this, I will also have to extract the root of that, but it becomes plus or minus. This is now just x minus 4, correct?
Yes.
Yes. So the square root of x minus 4 squared is x minus 4. And extracting the root of the other side, that's plus or minus the square root of 5. Yeah. It just so happens. So you really don't need to square x minus 4 squared, because we're dealing with square root property. So you know that x minus 4 squared, parenthesis, you can extract the root. So what will be the final answer? Yeah, transfer 4 to the other side, right?
Yeah.
It'll be 4 plus or minus the square root of 5. Any question there? No problem?
Mhm.
Okay. So I think those are some possible types of problems that we can have on square root property. So, of course, the first thing you'll have to do is do some simplification so that it will come out like a square is equal to a constant. So your square may not necessarily just be x squared, but it can be a binomial squared. Right? But yet, you use the same process. Okay. Yeah. Let's now move on to a much more beautiful way of solving a quadratic equation. And then we'll go to the more simple later on after okay. We now talk of completing the squares. Okay. Solving a quadratic equation by completing the square. If you look at x squared plus 4x plus 1 is equal to 0, it's difficult. If you talk of factoring, it's impossible to get a 4x by just the factors of x squared and 1. All right? That is not also a perfect square trinomial because, the middle term is 4. So we need to do something in order for us to solve this equation. Okay? And we call it completing the square. So if you cannot factor, you cannot use the square root property, then let's try completing the squares. Okay. So, in this problem, of course, as we said, our quadratic equation general form is ax squared plus bx plus c. Okay, is equal to 0. So we look at the coefficient. Our a there is 1 because the coefficient of x squared is 1. Our b is 4 because the coefficient of x is 4. And our constant is a 1. So whenever we do completing the squares, it's important to identify your a, your b, and your c. All right. And so it says, if you have a quadratic equation that cannot be factored, all right, then you just have to first, as usual, you put it like the x squared plus 4x is equal to minus 1. I already transformed it to x squared plus 4x plus 1 is equal to 0. So equate it to 0. And then the next thing you do is you divide the middle term, which is your b, by 2. So your b is 4. Divided by 2 is 2, okay? All right, let me use my laser pointer. So it says, multiply the b term, which is your 4, and by 1/2, or you get the half. So divide 4 by 2, which is 2. And then you square it. Okay, so it just so happened that it is also 4, but you know, in other cases, it will not be like if it's a 6, then 6 divided by 2 is 3, and then you square it, then it will become a 9. But in this situation, it's also a 4. So b divided by 2 is 2, you square it, 4. And then add that b squared, 1/2 b squared, to both sides. So I now have x squared plus 4x. So you change it to minus 1 there. X squared plus 4x. In that x squared plus 4x, add 4. In the minus 1, you also add 4. Okay. So you now have x squared plus 4x plus 4 is equal to 3. Because minus 1 plus 4 is equal to 3. And you now know that x squared plus 4x plus 4 is a perfect square trinomial. So the reason why we are adding 1/2 b squared to your equation, both right and left, we want our left side of the equation to be a perfect square trinomial. So x squared plus 4x plus 4 is now a perfect square trinomial, and we can now factor. So you now have x plus 2 squared. That is now the factors of x squared plus 4x plus 4 is equal to 3. And then we embark on the square root property. So we are now using here the completing the squares, at the same time the square root property. Because now we have the x plus 2 squared, you know, you can extract the root, and you can also extract the root of the square root of 3, although of course the answer is not a perfect one. So x square root of x plus 2 squared is x plus 2, the one that we did a while ago, is equal to plus or minus square root of 3, and therefore transfer minus 2 to the other side, the one that we did in our previous problem. So you now have your x is equal to minus 2 plus or minus the square root of 3. So the two solutions are minus 2 plus square root of 3 minus 2 minus square root of 3. So anyway, I am reading it through. We will be solving this, okay? Let's do this step by step in our next exercise, and then you will practice on what to do. So the idea here is that if you have a quadratic equation, transfer the constant to the right side. Then get half of the middle term and square it. Add to both sides of the equation. And the left side will already be a perfect square trinomial. And then factor that, and then extract the root, and then you finalize your answer by simplifying it. Okay, so maybe that would be more clear when we now move on to an example. All right, so let's have this, and you join me. Okay, I'll ask you questions, and then you can give the answers in the process. We'll try to solve this quadratic equation by completing the squares. So of course, the first thing is, yes, what will be your A? It's good to do that. What will be your B? What will be your C? Sorry, why did I put a 0? Okay. So our A is 1,
One.
right? Okay. Our B is
Is it
Three.
-3 or 3?
minus. Okay, don't forget to put that -3. And of course, our C is -5. I just want to make sure that we are clear what your B is. But it's the B that is important to us, okay? So
Okay.
then the first thing is we say x squared minus 3x is equal to 5. We always do that, okay? Isolate the constant to the right side. And then we divide b by 2 and we square it. So this is now minus 3 over 2 squared. And which is now 9 over 4. So then what we will do is we say x squared minus 3x. We add 9 over 4 to this side and add 9 over 4 to the other side. And we completed the square of x squared. This the x squared minus 3x. When we added a plus 9 over 4, that trinomial is called perfect square trinomial. And I think you know how to factor the perfect square trinomial. You get the square root of 9 and the square root of 4. That will now be 3 over 2. And because it's minus 3x, then this is now x minus 3 halves squared is equal to, simplify this, that's 29 over 4. Okay. Please just ask questions. Okay, let me erase this so that it doesn't interfere.
How did you find how do you factor? Is it because it's a perfect?
Square trinomial, okay?
It's
So
not a
when we
perfect.
added a 9 over 4 here, we actually made this polynomial a perfect square trinomial. Why is that so? Reason is because we said if it is a perfect square trinomial, the middle term is twice the product of the first and the second. That's why we divided this by 2 and then we squared, okay? So in other words, we're saying this is now 9 over 4, right? 9 over 4, what's the square root of 9? 9, that is 3. What's the square root of 4? It's 2. If I multiply this by 2, that will become 3, which is the middle term, right? Are we okay? So, to factor a perfect square trinomial, get the square root of the first, which is x. Get the square root of the second, which is 3 over 2. And follow the sign of the middle term. Yeah, so get the square root of the first, get the square root of the last term, and then change just the sign. If the sign of your middle term is plus, then it will become a plus. If the sign of your middle term is minus, it will be a minus. And if you want to check whether you are doing it correctly, we're saying if we square a binomial, all right, the middle term will be twice the product of the first and the second. So in other words, 3 halves times 2 is a 3, which is your 3x. So therefore, those are the factors. Is that clear? So please just tell me if, let me just erase this again. Okay. So we are doing a perfect square trinomial when we are adding b over 2 squared. And so just to make it, understanding that that is so, then our factors here should be just the square root of the numerator, square root of the denominator of your last term, and of course, the square root of x squared is x. So that will now be is equal to 29 over 4. So then we just use the square root property. So we get the square root of both sides. So now have x minus 3 halves is equal to the square root of 29 over 4 plus or minus. Take note that the square root is including the 4. So we can just have x minus 3 halves is equal to, the square root of 4 is 2, right? So it can be written as plus or minus the square root of 29 over 2. Where now the 2 is outside the radical sign. And so simplifying, we now have x is equal to, transfer 3 over 2 to the other side. That will now be 3 over 2 plus or minus the square root of 29 over 2. But we can put that in just one denominator. They are the same as 2. So you can have 3 plus or minus the square root of 29 all over 2.
So these equations will always have a perfect square.
Yes, because we are, let me just repeat that when we, okay, let me laser pointer. When we did this, when we got the, your b, okay, when you divide your b by 2 and you squared it and added to this part, what will come out will be, this whole thing will be already a perfect square trinomial. That's why we call it completing the squares.
Okay.
So when we added b over 2 squared, we are completing this thing. We made it as a perfect square trinomial.
Yeah.
Okay. Yeah, let's try so that you can practice and then you can ask question in the process. Okay.
So
All right.
this is
Let me erase first some of the things here so that it doesn't interfere. Okay. Okay. So try doing x squared minus 6x is equal to 13. So in the process, you can ask question if you get a little confused through. Try x squared minus 6x minus 13. It's equal to 13, not minus 13. This one.
Which one?
Yeah, that one that I put. X squared minus 6x equals 13.
Just now. Only just now. I mean, you would say it. Yeah.
this is the perfect loop.
Okay.
Okay, so
So what you really identify is the B, not necessarily the A and the C. It's just the B, which is the
Yeah.
coefficient of your X.
mm,
6.
So your negative 6, you divide by 2 and you square. And add to both sides.
x equals 3 plus minus square root of 22.
Okay, let's wait for the others. and
I
see if
think
they agree with you.
Agree. I haven't
You-
found it.
First,
22.
so this is another way of solving a quadratic equation, right?
Yes. When you cannot factor, yeah, because x squared minus 6x is equal to 13. It's impossible to get a 6x at the middle. Okay.
Cannot factor.
Yeah, you cannot factor that. Yes.
Really? I
Yeah,
thought we could.
because 13, you're just using the factors of 13. The only factors of 13 would be 13 and 1. And how can you get a 6
Yeah,
as the middle term, right?
Now, what did you say it was?
yeah.
It's 3 plus or minus the square root of 22.
I agree.
Yeah,
you.
very good.
Okay.
Rachel,
Now
do you
I
agree?
faith.
Sign an agreement form soon.
Sine, you also agree?
Yeah, what did you say?
Yeah.
Okay. It says x. Oh, sorry. I have no pen. Okay. X is equal to 3 plus or minus the square root of 22.
So we used to solve quadratic equation by substituting.
Huh?
So by substituting in that formula.
Yes, I agree. I got that.
Very
When we-
good. All right.
Actually,
Yeah.
easy than
Reason is you now have your 6. So it is now 6 divided by 2 is 3 squared, right? 3. Okay. And then you square. So you add 9 to both sides. Okay. Let me erase a lot of these things here. All right. So everybody agrees? Okay. Okay, so just to we're now saying minus 6 over 2 squared is equal to minus 3 squared is equal to 9. So you now have x squared minus 6x plus 9 is equal to 13 plus 9. This is now x minus 3 squared is equal to 22. X is x minus 3 is equal to plus or minus square root of 22. Isn't that easy? And it's cute, all right? And it says 3 plus or minus the square root of 22. So beautiful. So you don't need to, there's no, well, of course, if you can factor, use factoring. If you can use a square root of square root property, use square root property. Otherwise, if you cannot use any of those two procedures, then we complete the squares. So,
Mhm.
aren't you glad about this completing the squares?
Mhm.
All right, here.
What is it?
Yeah.
It's the same thing.
Well, it's good.
Now, when your A is not equal to 1,
Oh.
I
Also
would
that is
rather make sure that you are changing that to x squared plus, divide everything by 4 before you do the completing the squares. Because it's kind of a little difficult when, yeah. So we should have x squared plus whatever. So transform it to something, okay? So dividing that by 4, we are transforming that to just, okay, so that we'll begin from there. X squared plus x minus 3 over 4 is equal to 0. So that you'll now have x squared plus x is equal to 3 over 4. Then that's the one that you'll have to complete the squares. So you always make sure that your leading coefficient is a 1.
minus 1/2 plus minus square root of 1. Is there a square root of 1? What is square root of 1? Just 1.
X plus one over two.
Yeah, square root of 1 is just 1 automatically.
1, yes. What's your final answer? I think that one you can give the answers as two numbers. So I think you did this, right? X squared plus x plus 1/4
The 1
equals
half
3/4 plus
and
1/4.
minus 3 halves.
You now have x plus 1/2 squared is equal to plus or minus. No, not yet. It's equal to 1. Is equal to 1. All right. Yeah. Looks like that one you can do by factoring, but I just want us to. Okay. So this is 1. So you now have x plus 1/2 is equal to plus or minus 1, right?
Uh-huh.
Yes. So what will be your final answers?
So 1 half or minus 3 half.
Okay. So it will now be minus 1/2. You transfer to the other side. Plus or minus 1. Okay. So what will be one of the answers? Yeah, if it's not a square root, I would want the answer given, all right? So minus 1/2 minus 1, it will now be minus 1/2 minus 1 and minus 1/2 plus 1, right? So minus 1/2 minus 1 gives you minus 3/2, correct? Minus 1/2 plus 1 gives you 1/2. So those are your two answers. Minus 3/2 and 1/2. Are we okay? Oh, okay. Another one, and then we can proceed with just that last thing on completing the square. So 3x squared plus 4x minus 15. Let me see how long it takes you to do completing the square so that whenever I give a quiz, I know how long it takes. Okay, so try to do it fast. So always divide by your A.
What the answer?
Answer.
Okay. 5/3
Uh-huh. And
and -3.
okay, very good.
Thank
Just say if you agree.
Yes, agree.
You agree, Sine?
Not yet.
Not
Sine.
yet. Okay.
I'm getting fine.
So I think you started. I just want to just for the start. You started with this. Right. All right. Okay. Yeah. Because you divided everything by 3.
Yes.
All right. And so what did you add? After okay, so then you did this plus 4/3x is equal to 5. What did you add to both sides?
Added 16/9.
Okay, you divide 4/3 by 2. Or you multiply by 1/2. So you now have 4/3 times 1/2. If it is not if it is a fraction, I'd rather have you multiply by 1/2 because sometimes you divide by 2, you think it's a little. So that will now become 2/3, right?
Hmm?
You divide by 1/2 or multiply by 1/2. 4 and 2 will be 2/3. That's the one that you will square. So you add 4/9, not 16/9. Is that okay?
Yes.
Yeah, all right. So we will now add 4/9. We add 4/9 here. So please be very careful with what you are adding. So always remember, you divide or you multiply the middle term by 1/2 and square. So the left-hand side is already a perfect square trinomial. So it will now be x plus 2/3 squared is equal to the 49/9. 5 plus 4/9 is 45 plus 4 is 49/9. All right. Therefore, you now say x plus 2/3 is equal to square root plus or minus. So extract the root. It is just 7/3. Square root of 49 is 7. Square root of 9 is 3. So you'll now have x is equal to minus 2/3 plus or minus 7/3. Bethany, you also you got it too? Minus 5/3 and minus 3?
No, I got lost somewhere in the
Okay,
middle.
so let's go through it. So I just want to make sure that we are clear. Adding 4/9 is okay? Yeah?
Yes.
Yes, all right. So up to this point, before I extracted the root, so I'll remove that.
It's
Okay.
B and that's the confusion.
Yes. So as soon
Okay.
as you got this part, you know that the x squared plus 4/3 x plus 4/9 is already a perfect square trinomial. So we now have this as our factors. Yeah. So let me say that when you are adding 1/2 of the middle term squared, you are making it a perfect square trinomial. And therefore, you just have the way to factor the perfect square trinomial, which is, you know, the square root of 4 and the square root of 9, which is 2/3. And then simplify. 9 times 5 plus 4 is 49/9. Okay. And then we just use the square root property. The square root of x plus 2/3 squared is x plus 2/3. Square root of 49 is 7. Square root of 9 is 3. And then just simplify, transfer the constant to the other side. So now plus 2/3 is minus 2/3 plus or minus 7/3. And then simplify that. So one is a plus, minus 2 plus 7/3. The other one is minus 2 minus 7/3. So your answers would now be 5/3. Okay, so the answers for this would be x is equal to 5/3. And the other answer is minus 3. Any question?
No.
Yeah. So for the just the next 5 minutes, let us understand fully the completing the squares, okay? And we will learn how to find. Are you familiar with the quadratic formula?
Yeah.
Yes. Don't you know that the quadratic formula was obtained from completing the squares?
Oh,
We'll
no,
just
I didn't.
compare. Yeah. So the quadratic, and once you know the quadratic formula, if you just don't want anymore to do factoring, you don't want to do square root property, you don't want to do completing the squares, the quadratic formula will be a one formula that you can use for any quadratic equation. So it is now the complete solution for any quadratic equation. We call it quadratic formula. So I just want us to see the relationship between completing the square and quadratic formula to end our discussion today, so that you see how wonderful a completing the square would be that would lead to quadratic formula. So what we were doing a while ago, we will just do this in a more general term, okay? So I'll just use my laser pointer. So as usual, in our previous discussion, okay, we say make sure that your C is at the right-hand side, all right? And then, for you to do completing the squares, make sure that the leading coefficient is 1. Therefore, we divide everything by A. You were doing that a while ago. So ax squared divided by A is x squared. X divided by A is B over AX. Minus C divided by A is minus C over A. And then we complete the squares. You get 1/2 of the middle term. And our middle term is B over A. So 1/2 of B over A is B over 2A. We square it, B squared divided by 4A squared. And add this to both sides of the equation. Right? Yeah, so we're doing it in a more general term. So we're adding B squared over 4A squared to this side. We're also putting B squared over 4A squared to this side. We decided to put the B squared over 4A squared ahead of minus C over A to make it a little bit more simple when we move on to our quadratic formula. But just the same, we are adding b squared over 4a squared to both sides. All right. So moving on. Okay, so that we now see the, okay. So because it is already a perfect square trinomial, we factor. So the factors of the previous one is x plus b over 2a squared. All right. And this one will now be b squared minus 4ac over 4a squared. And then we extract the root. So x plus b over 2a, because this one is now, we extract the root of this, and it's plus or minus the square root of b squared minus 4ac over 4a squared. Okay. But the square root of 4a squared is 2a. Transfer the b over 2a to the other side. The final formula is x is equal to minus b plus or minus b squared minus 4ac over 2a. So this is now what we call the quadratic formula. So that, just for, once you know your A, once you know your B, once you know your C, then you just substitute. And you'll get your answer. Okay? So from completing the squares, we were able to arrive at the quadratic formula. So
we
yes?
right? We could have used this formula.
Yeah. But of course, in the quiz, I will still ask you, do this by completing the square. Okay? I will still want you to know how. So it was good to learn completing the square, because the mathematicians were able to formulate this quadratic formula, which is a one solution for all, one process for all, out of completing the squares. So it's important to understand how completing the squares was done, so that at least you would appreciate how quadratic formula was obtained. I don't know how you did appreciation, but for me, I just felt like, wow, it is great, because nowadays, especially when we're dealing with what's that, decimals, you have decimals in your quadratic equation, then just use the quadratic formula and you'll be able to get the answer. Of course, you need your calculator. Okay. All right, so we will be using the quadratic formula, but before we leave, I just thought, I find some nice lesson out of this, completing the squares. Once you complete the squares, you will have some beautiful equation, all right? And it's very easy to factor. And then later on, you can do quadratic formula. So, when I was doing this, I was thinking, I think my life sometimes is a mess, all right? And I need to be completed. And the only time I can be complete is when I add, you add the 1/2 square to both sides of the equation. So my equation will become more complete if I add somebody to my life. And that is when I add Christ in me. So in Christ, we have been made complete. As Colossians 2:10 says, and you have been made complete in Christ, who is the head over every ruler and authority. And from having been completed by Christ, just as we moved on to a quadratic formula, we now have a complete formula for any problem we have, all right? Because Christ has already completed us. So that's why I love this completing the squares that moves on to quadratic formula, because I can relate to my life, not just spiritual life, but my physical life, with Christ having completed me. So I hope it is a good way to end our lesson. So I'll be giving again homework to do this factoring and until completing the squares, and we'll do quadratic formula the next time, and we'll finish our chapter. Actually, we're only just dealing with the second chapter. Maybe the next chapters we'll do it fast. I'll just deal with some I'll just choose what needs to be done. And you are also to do your reflective journal, okay? So the next reflective journal, whatever you learned last Thursday and what we have learned today. And I think that. So please,
Oh.
okay, that's all for today. And I hope you will have a good day ahead of you. So just look at the bulletin board, the dashboard,